Another method of finding volumes, it's a shell method. Suppose I have a long cylindrical shell. The length of that shell is h, and the width here is w. And let's let p equal the distance from the center of the shell up to the center of my rectangle here. Then I'm going to have an inner radius and an outer radius, where since p is the average, the inner radius is p minus w over 2 is the width, and the outer radius is the p plus w over 2. So when I go to find the volume of the shell, it's volume of the solid cylinder minus the hole, or pi p plus w over 2 squared h minus pi p minus w over 2 squared h. And so I wind up with, when you simplify this, 2 pi p, where p is the average radius, h is the height of the rectangle, and w is the thickness. Now, the way we've been describing this, the thickness is clearly, in this example, delta y. The height we're going to call h as a function of y. And then the average radius, we're going to use a p of y for the average radius instead of r, all 2 pi. So the volume of my shell here is a very straightforward formula. Now suppose I add up all of the rectangles, all of those thin shells. Yeah, I can see the picture gets very, very complicated. So if this is one of my shells, where this is delta y and this is h, and if I add them up, take the limit as delta x goes to 0, or delta y goes to 0, then I'm going to have the volume. For these, I want you to actually draw a picture like this, where you identify h, y, and p, where this is my axis of rotation. So the formal definition is a volume. When I rotate about a horizontal axis, the volume is 2 pi, the integral from c to d of p of y, where this is the distance from the center of the rectangle to the rotation axis, and h is the height of the rectangle. While if I have a vertical axis of rotation, okay, then I'll draw in my representative rectangle. I clearly have delta x. H will be still the height of the rectangle, and P of x is the distance from the rotating axis to the center of the rectangle. Now here are some steps I want you to follow. Always draw a diagram on your representative rectangle. Identify dy or dx. Identify your limits of integration depending on your dy or dx. Now P is the distance from the axis of rotation, center of the representative rectangle, while h is the height of the representative rectangle. And this is going to be usually f of x minus g of x. Pen's not working. All right, or f of y minus g of y. And then use your volume equation. Let's do one. Find the volume of the solid formed by revolving y equals x minus x cubed and the x-axis about the y-axis. So the first thing I want you to do is draw your diagram, which we have. Draw your representative rectangle. And when I do, there's my representative rectangle, and I have delta x. When I know I have delta x, that means I have to have everything else in terms of x. A and B, P of x, H of x, all of that. So in this example, I want it between 0 and 1. So A and B, A is 0 and 1. H of x is the height of the rectangle. The height of the rectangle is always top minus bottom. The top function is x minus x cubed. Now what's this bottom function here? It's just x equals 0. So it's x minus x cubed. Now what is p? Let me switch colors here. P is the distance from the rotating axis to the center of my representative rectangle. And in this case, no matter where I put it, it's just going to be located at x. So in this case, p is equal to x. All right, now we want to come back. Have I identified everything? Yeah, I'm going to have delta x, so I know the volume is, now the volume of a shell is 2 pi, the integral from a to b of p of x, h of x, dx. And yes, I want this formula right here every time. So this is 2 pi. I identified a and b as 0 to 1. P is just x. H is x minus x cubed dx. All right, now we just have a straightforward calculus problem. We can just integrate this. Integral from 0 to 1 of x squared minus a fourth dx. 2 pi times x cubed over 3 minus x to the over 5, evaluated at 0 and 1. So this is 2 pi times 1/3 times 1 cubed minus 0 cubed minus 1/5 times 1 to the 5th minus 0 to the 5th. And when I solve this out, I wind up with 4 pi over 15.